Hello and welcome to another video. In this video we're going to be working on count triplets that can form two arrays of equals XOR. And there's going to be several parts in this problem, and we're going to try to understand each one and then combine them all into the optimal solution. So the first part, what do they actually mean? So you have an array and you want to select three indices, I, j, and k, where I is less than j, and then k and j can be the same, but j has to be basically in between I and k. So j has to be greater than I, so you have to have at least two different indices. And the subsection of I to j minus 1 equals some value, and the subsection of j to k equals some value. And those two values have to be equal. And so return how many different indices of I, j, k you can have to do this. So in this first example, if I is 0, so here's I, and j is here, and k is here, the subsection of I to j minus 1 is just 2, and then j to k is this, so you want to XOR both of them, so 3 XOR 1, and you get 2 as well, so those are equal. In the second example, it's 0, 2, 2, so if j is over here, and k is the same value, that means I to j minus 1 is this. So 2 XOR 3 is 1, and then the last part is this, so you get 1 equals 1. And then you have 2, 3, 4, so I is here, j is here, k is here. So the I to j minus 1 is this, and then this thing is 1. So they're equal again. And 2, 4, 4, so I is here, j is here, and k is here, so the subsection of this is 7, I think. Yeah. So 1 XOR 6 is 7, and then this thing is 7. So that's kind of how you do it. So the first thing to realize is if I have a bunch of numbers, let's just try to figure this out. So if I have an array that has a bunch of numbers, like, you know, some number, let's just say I to k, I'm basically getting the entire array, right? Because I to j minus 1 is some part of it. Like, let's just say we have some array. Let's just draw it out. So we have this, and let's just say, like, we have some array, and let's say maybe I is over here. And yeah, so let's say I is over here, j is over here, k is over here. Well, if you think about it, you're first getting the XOR of these elements, and then you're getting the XOR of these elements. And they have to be equal. So if two elements are equal, so if x and y are equal, that means x XOR y has to equal 0. Because if they're the same number, a number XOR with itself is 0. So what that means is if you take the XOR of this chunk and the XOR of this chunk, and you XOR them together, it's 0. And also, XOR works kind of like addition, where like the order doesn't really matter. So you're basically saying, if I add these together, and I add these together, and then I add the whole thing together, it's 0. It's the same thing, it's just adding up the entire sequence, right? So basically, you can rephrase it as saying, if I take some I and some k, that means that I need this whole section to XOR to 0. And the j value doesn't actually matter. So let's just take a smaller array to show that. So let's say our array is here. So I is 0, k is 3. So let's say what happens if j equals 1. So if j equals 1, we would have this index 0. So I'm just going to write the index, but basically or actually I can draw it. So the first array would be this, and then the second array would be this. But we're still XORing the entire thing, right? Because if this equals this, then the XOR of the whole thing is still 0. Now what if j is over here? Well, then we would get this and then this, but we're still XORing the entire thing. So it doesn't matter. And what if j is right where k is, which is allowed? We're still XORing the entire thing. So for a given I and k, the possible, assuming this subarray XORs to 0, the number of locations you can put j is just k minus I believe. So we can write that. So for a given I and k, number of j locations is k minus I. So that's like the first thing you want to recognize for this problem is what you're really doing is you're just saying like, okay, I'm going to find a bunch of subarrays that actually XOR to 0. And then for every subarray that XORs to 0, like let's say this one does, 2 to 8, then that means I can make I has to be 2, k has to be 8, but then j can be any one of these values, and it will always work because you're basically doing the XOR of the whole thing. So 2 to 8, you'd get 6 different locations for j, right? You can put it at 3, 4, 5, 6, 7, 8. Assuming I is here and k is here. So that's how you would get like that. So if you know the start and end index, that the subarray is 0, so let's write that. So we're looking for subarrays with XOR of array to be 0, and we need it to be contiguous. And then the number of subarrays, once we find one, like the number of, so anytime we find a subarray, we can just figure out, okay, given the subarray, j can be at all these different places. So how do we do that? Like basically, if our question is find the number of subarrays in this thing that the XOR is 0. So this is the same as subarray sum minus k. So let's say instead of being asked, what's the like XOR works kind of like addition. So let's say we're being asked, instead of the XOR of the subarray to be 0, if we're asked to the total of a subarray to be 0. So just like given an array, find all the contiguous subarrays with a total of 0. Well, that is just a prefix sum problem. So you can just maintain a prefix sum of the array. So let's say your total here is like 10, and your total here is 10. That means the subarray between those has a total of 0, because you went from 10 to 10. Same thing with an XOR. If I have an XOR of this section being 10, and I have an XOR of this whole thing being 10, that means the part in the middle has to be 0. Because how do you go from 10 to 10 with an XOR? You have to XOR it with 0, right? Like this is the only way. So hopefully that makes sense. So essentially now we can figure out like how many, like we can figure out when we know that a subarray has an XOR of 0, we can just maintain like a running prefix total. And then anytime we run into that number, if we've seen it before, that means we have a subarray that fits our condition. But then how do we know like how many there are? Like for example, let's say the XOR of this prefix sum right here is like, let's say this is our array, and when we maintain our running XOR, our XOR here is like a 5, and let's say it was a 5 over here. That means that this whole thing XORs to 0, right? Because, like I said, in order to go from a 5 to a 5, you have to XOR with 0. There's nothing else that would give you that value. So if I know that like this is one of them, I know the length of it. The length of it is 5. And then where's the number of j locations I can have? It's 4. So it's pretty easy if there's only like a couple subarrays where that happens. But the problem is, we can't just like maintain a count of how many times we've seen the number. Because let's make this a little bit bigger actually. Actually, we have it here. Okay, so we have this array of just like some XORs I've made up. So this is the prefix XOR. So this is not like, this doesn't mean like the value in here is a 1. It means that the cumulative total is a 1. So what this value represents is the XOR of every single value in an array from 0 to 5. And what this represents, for example, is the cumulative value of every array, or cumulative XOR in the array from 0 to 3, and so on and so on. So if you run into a value twice, like let's say this value and this value, that means that the XOR of the subarray between those has to be 0. Because we went from a 0 to a 0, that means that the XOR of everything between those, which is this in this case, has to be 0. So we can try that. So we can get 4, 5, and 6. Actually, so I think the reason this is not the case, oh yeah, right, this is not the case, is because, sorry, so this actually wouldn't be the case because these aren't the actual numbers in the array. So really what the numbers in the array would have to be like 4, and then 1, and then I think like 3 would give you a 6. Yeah. So it'd be like this, right? Because if you XOR these numbers, that would give it to you. Because you'd go 0, XOR with a 4, that would give you a 4. You'd XOR 4 with a 1, that would give you a 5. And then you'd XOR 5 with a 3, and that would give you a 6. And now if you XOR all of these together, this would give you 0. So it's a little bit more confusing with XORs as opposed to like totals. But I would definitely work on like prefix sums first before doing this problem. So this is actually going to be this, which gives you... oh, right, there's one more number. There's one more number. So this will give you 6, and then now we need basically a 6 here. So it'll be like that. Yeah, because we're going from 4, 1, 3. Yeah, so these are the numbers. So then it would give you 4, 1, 3, 6, which is this. And the XOR of this whole thing now is 0 because every single number occurs twice. So this would be 0. So hopefully that makes sense how like a prefix XOR works, just like a prefix sum. But essentially, let's get back to the actual important stuff. So if we know that like 0 occurred at this index and we run into it again, then we know that like, okay, if this 0 occurred here, our I value has to be the index right after it. Like we know our array is this. So I has to be here, right? Like I was saying, K has to be here, and J can be any one of these, which is fine if we only run into 0 like twice. But what if we run into 0 a bunch of times? Now for this 0, there's going to be a bunch of subarrays that have a XOR that's equal to 0, basically. So like if we run into this, any other 0 that we've run into before, that subarray will give you an XOR of 0. So for example, this should give you an XOR of 0, and this should give you an XOR, or not this, this should give you an XOR of 0. Right? Because basically we're saying we XORed a bunch of values and we got 0. So how do you XOR a bunch of values and get 0? They have to start at 0. So hopefully that makes sense. So basically, like anytime we run into a number, we can use every other number before to make a subarray. So if I have like 6 zeros here and I run into another 0, that means I can make 6 subarrays. But I don't really care about the number of subarrays. I need to know for every subarray how long is it, because then I know how many J's I can put in, right? So if the subarray is, you know, X units long, and it has to be at least 2, then I can put J in X minus 1 locations. J just has to be greater than I. So how do I do that? And the way to do that is we're going to maintain 2 things. We're going to maintain the count of subarrays we've seen, and we're also going to maintain a cumulative total of indices, and I'll explain why that is. So let's just say we run into this 0, and we say, okay, have we seen a 0 before? If we have, then the subarray from that 0 to this 0 is going to be a valid place for I and K, which is this, which is fine. And so where can we put J? Like I said, we can put it here, here, or here. So that should give us 3 results. And so if we know the index of where we were, and the index, instead of the index of where we were, we're going to store the index. So for example, if 0 is here, we're actually going to store the index of where we're going to put the I when we've seen this number. So if we've seen this number, this is the number for the empty array, that means the index of the I will actually go is the one right after it. So it'll go right here. And then K is the current index we're on. So basically this will be index 0 for this 0 here. Now for this 0, this will be index 4, because if this is 0, if we reach another 0, where can we put the I? We can put it right after it, right? So for a prefix sum, the actual subarray is the one at your current value up to, not including the previous value. So it's going to be this. So if we actually maintain a total of all our indices, let's just think about like how many J values we can have. Well, this is going to be 0. And so let's say we're running into like we're running into this value here. So we have this value stored. This is 0, and we hit a 7. So we can put a J at 7 different places, which is correct, right? So we can put it here, 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 as long as we don't put it here. And we can also use this subarray, and we're going to store this index as well. So instead of storing every single index, you only need to store the total of every index seen so far. And then we can just calculate how many J indices we have. Because basically now our problem reduces to like, let's just say we have like a left index and a right index. And the number of places we can put J is right minus left. Well, instead of storing every left index, our right will always be the same, right? Like when we're on some value, this will always be the right, and the left will be a bunch of different numbers. So instead of storing all of them and doing right minus left, like imagine our indices that we've seen is like 1, 2, 3, and our right is like 7. Well, we can do like, okay, let's do 7 minus 1 plus 7 minus 2 plus 7 minus 3. We don't need to do that. We can actually just total up our indices and have a count. So our indices is 6. right? And then how many, because we have a count of 3, we're basically going to have 3 7s. So we can just say, let's just take our right multiplied by the count and subtract our total. So in this case, it's going to be 21 minus 6. And if you actually do this, this is the exact same thing. So that's what we're going to store. We're going to store, and this is kind of confusing to be honest, so hopefully it makes sense. If you have any questions, you can always write in the comments. But essentially, for every single subarray we've seen, like this one, we're going to store the left index, and then we can just calculate how many J locations are there in O of 1 just by adding up, instead of storing the left index, we're going to store a total of left indices. So for example, when we're here, we're going to have the value 0 stored. We're going to have the value 4 stored because this is the first place you can put in an I for this subarray, right? So it's actually going to be this subarray. And we're going to have the value 8 stored, all combined into one. So it's going to be like 0 plus 4 plus 8. And when we reach here, the number of subarrays that XOR to 0, in this case, because we have 0, is going to be the number of zeros we've seen before, right? So it's going to be like this one, or this whole thing. And the number of J locations is basically the total number of the total for the indices times the arrays we have, which is 3. And then we're going to have our current value. So with 9 times 3 minus this thing. This is the number of locations. Actually, this is not going to be 8 times 3. It's just the total number of indices. So it's going to be this. So the right index will always be wherever we're at, and the left index is just going to be the total of all these things. So hopefully that makes sense how you do this. Basically, it's like given a bunch of left and right indices, instead of storing it, if right's always the same, you just multiply right by the count, and then instead of storing the left indices in a list, you can just add them up. And then from there, we can figure out the number of J locations, and then from there, we can figure out our result. So also, I showed this with 0, but let's say we ran into a 1 multiple times. So if we ran into a 1 here, we're going to say like, oh, have we seen a 1 before? Yes, we have. And we're going to store index 1 here. So this will be stored here. And then we just say, okay, so the number of J locations we can use is 8 minus 1, which is 7. Because there's only a count of 1 here. And so this subarray is going to XOR to 0, and we can put a J here, 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 here. Did I do that right? Oh, no, never mind. We can't store it here, right? So it has to be these 7. Because if there was a 1 here and there's a 1 here, we need this subarray, so the I has to be here, and J can't be I. So hopefully that makes sense. So let's get into the code. And if you're still not like, it's kind of confusing. So hopefully you'll be able to see the code and then understand it better. Okay, so we're going to store a couple things. So we're going to store a map of counts, and the count is going to be the number of times we've seen a number before and the total for all indices. So we'll say it's going to be an int array for our actual value. Okay, and we're going to have our like running XOR. We don't need to do a prefix sum, we can just do a running XOR, and we're going to have a result. And remember, for these prefix sums, you basically want to store that you've seen 0 right at the start. So 0 represents the empty array. So if I run into 0 again here, I have seen it before, and this whole thing XORs to 0. So that's how you know you've seen it before. So we can do that. So we can say counts put 0. And we're going to put in a new array. And so the first value will be the count, and the second value will be the running total. So because the 0 is technically a location like -1, our first I can be put here, right? Because this represents the empty array, so I can be the index right after it. So we're just going to loop through the array now. And basically we're going to maintain a running XOR. And so what we're going to do here is we're going to say, if we've seen this before, then we can calculate how many different like combinations you can have, because we're going to calculate like the length of each subarray in O of 1. And then for all of those, we can put J in every location other than 1. So we can say if counts contains key, I think. Yeah, so if this key is in here, then we're going to do some math. So we'll say int array. So we need to get this like value. We can say like value counts get XOR. And we need to get these two things. So we need to get the count, which is going to be at index 1 or index 0. value. So value 0 and the index total. Okay. So now the number of subarrays we're going to have, like I said, is the number of times we've seen this times our I, right, our current index, minus our index total. Because basically it's this thing that I showed here. So the number of times you've seen is how many subarrays you have. The right index will always be the one we're currently at. And then these left ones will just be the total. So this is going to be index total. And it is hard to get this like index exactly correct, so you kind of have to play around it to make sure you get the actual right location. So now we're going to store this index. We're going to add the index we've seen the number to the total. But remember, instead of storing this index, we're going to store this index. Because if this totals to 1, the next place we can put an I for our next thing that totals to 1 is actually the place right after it, right? We're not including this one, we're doing the one right after. So we're going to say here that the index total, we're going to add I plus 1. And we're going to increment the count because we've just seen this thing again. And we're going to put this new array into the hash map. So okay. And otherwise, if we haven't seen it before, then we'll just have a default value. So our default value can be a count of 1. And our index total won't be index total, it'll just be I plus 1. And when we're done with the loop, we just return results. Right. And there we go. So hopefully it makes sense. Definitely really confusing. Yeah, like I said, if you have any questions, let me know. And hopefully you could see like all the little parts I did and how to combine into this. If not, I would just try to do it like a simpler way. Like one thing you could do instead of doing this like index total thing, you can just try every start index and end index, and you can still do the prefix sum, and that would give you like an n-squared solution. But hopefully that makes sense. I think you can also actually just brute force it as well, because it's only 300, so I think you can just brute force every index. But you know you don't need to do that. You can just brute force i's and j's, because if I and j works, I think you wouldn't even need a prefix sum. You can just brute force i's and j's, and then if the prefix, if the XOR from I to j is 0, sorry, you would brute force i's and k's. So if the XOR from I to k is 0, then j can just basically be put into the length of that array minus 1 values, because j just has to be greater than I. And then it doesn't matter where you put it, it's going to be equal to the same thing. But in this case, this is going to be n and space. So we didn't need to use the prefix sum, and we just use a dictionary, which has the value and the number of times it appears, and worst case, that's going to be n. You can use a prefix sum, but the reason you don't really need it, you can just keep a running total, is because we're storing it in here. So in this count, we are storing like the prefix sum already, kind of, and like all the indices where it occurred. So this is basically where, so instead of storing it in like a traditional prefix sum array, we're just storing it in here basically. So yeah, hopefully that makes sense. Definitely a hard problem, I'd say, especially for like for this solution, and confusing if you haven't done a lot of bit manipulation. But yeah, as always, if you have any questions or anything, write in the comments. And if you like the video, please like and subscribe to the channel. And I'll see you in the next one. Thanks for watching.